Now, I came across this example online, and I just wanted to record a video about the relationship between sufficiency versus necessity in the LSAT. Now, this relationship is important, and it's important to understand this for arguments and some question types on the LSAT. And I just wanted to record this video to just explore this concept further with this specific example that we're given here. So let's start it off with the passage. Trees that shed their foliage annually are deciduous trees. Black oak trees shed their leaves every year. Therefore, black oak trees are deciduous. Now, immediately, this is a very strong argument. So let's diagram it here. And just a disclaimer, I'm not an expert on the LSAT. I'm just recording this video to test my understanding of the LSAT and hopefully perform well on it in the future. So, trees that shed their foliage annually are deciduous. Now, immediately, I'm just going to write trees that shed their foliage are deciduous. Now, what is a sufficient and what is the necessary condition here? Well, this is the sufficient condition, and this is the necessary condition. Now, why is that so? Well, I like to diagram it through subsets and supersets. So immediately in my head, I think, what's the all-encompassing idea here? Well, it's deciduous trees, because all trees that shed their foliage are deciduous. Now you see this relationship here. If you're in this subset of trees that shed their foliage, you're also in this a set or superset of trees that are deciduous. Now, that means that D is the necessary condition for the trees that shed their foliage, and trees that shed their foliage is sufficient for deciduous trees. Now let's look at why it isn't the other way around. Well, is trees that shed their foliage necessary for deciduous? Well, no. Well, deciduous trees can have other characteristics that aren't necessarily trees that shed their foliage. If you're kind of a math person, you can think of it like there's extra white space here in this subset. That means that it is not necessary for trees to shed their foliage to be deciduous. And we can do this the other way around. Is it sufficient for trees that are deciduous? Is it sufficient for trees that are deciduous to be trees that shed their foliage? Well, no. You can be here or you can be here. You don't have, just because you're deciduous isn't sufficient enough to assume that you're a tree that sheds your foliage. However, it is sufficient to assume, because you're a tree that sheds your foliage, is sufficient to assume that you're deciduous because you're part of that all-encompassing set. And it is necessary for you to be deciduous. D is necessary for you to be a tree that's trees that are deciduous are necessary for trees that must shed their foliage because you're immediately part of that set. Understanding that relationship between sufficiency and necessity is crucial, and not confusing the two is also very important. Now let's look onto the second part of this passage. Black oak trees shed their leaves every single year. Now we can do this here. Now black oak trees shed their leaves, or shed their foliage. So what's the all-encompassing idea here? Well, we know that all black oak trees, black oak trees, not all black oak trees, shed their leaves every year. So they're part of the tree shedding or tree foliage producing superset. And then we can also imply here that this is the sufficient condition and this is the necessary condition. Now, if you look at the relationship between these two sets, well, we can produce a third set that really highlights why this is a strong argument. Now, what is the ultimate encompassing idea here? Well, it's deciduous trees, and what's part of that? Well, trees that shed their foliage, and what's part of that? Black oak trees. Now, we look at the conclusion here. Therefore, black oak trees are deciduous. Well, is this true? Yes. Deciduous is necessary for black oak trees. So, because deciduous is the ultimate all-encompassing group that highlights the relationship between black oak trees and trees that shed their foliage and deciduous trees. Now, if you'd like it to do a diagram, through a diagram, well, we can just do that right now. Trees that shed their foliage are deciduous, and all black oak black oak trees shed their foliage. Therefore, it is safe to assume that black oak trees are deciduous. Now, you see this, why this is a strong argument in two different ways that really solidifies or conceptualizes the idea of strength and validity in an argument, and that's through a subset and superset diagram and just a basic logic or arrow diagram here. And I think that this is a pretty cool way to just physically show and not, mentally understand why or intuitively understand why this is a strong argument. It's cool to see why this is strong through diagramming. So that's all I have, and understanding the importance of sufficiency and necessity is important. And please correct me if I'm wrong.